Our next team presenting today is actually also from the University of Florida. The team name is UF-Aceiti Acere. The topic of the project is effective energy production as a solution to Cuba's Oil for Doctors program. Let's have the floor.
It looks like a marathon bomb.
We tried, we were told that, and we tried to keep it as conceptual as possible because of that.
There.
It's on.
Laser?
Yeah.
Is it laser as well? Which one?
Go see
Okay. So I'm clicking?
Oh, I got it. Good morning. My name is Regina Rodriguez. I'm a fifth-year environmental engineering.
Hi, my name is Eric Bulnes. I'm a fourth-year mechanical engineering student.
My name is Jose Sera. I'm third-year mechanical engineering.
And I'm Francisco Ferrer. I'm a second-year chemical engineering student.
Today we're going to talk to you about an effective energy production as a solution to Cuba's Oils for Doctor program. Our name is Team Aceiti Acere because of oil and getting that accounted for. So in order to talk about our implementation and how we plan to account for this problem, we got to tell you a little bit about the Cuban economic and energy stability. So for years, Cuba had been trading sugar for barrels of oil and medicine with the Soviet Union. With the fall of the Soviet Union, different systems could have been implemented, but due to the American embargo, some of those were limited. One major option came about due to the Venezuelan oil trade, and now they trade oil for medical experts. So the Venezuelan agreement, El Convenio Integral de Cooperación, was signed in October 2000, which called for 31,000 Cuban doctors and dentists to be provided to the Venezuelan government for treatment and for training of 40,000 medical personnel. In exchange, Cuba receives 100,000 barrels of oil per day, which is worth over $7.5 million a day, almost $3 billion a year. So this agreement can be looked at different ways. So there's a lot of pros to it. Cuba meets its energy needs. There's a lot of production in that environment. There's $6 million gift of these barrels of oil. And there's also an excess of production that they get from the trade as well. The one thing we do have to look at is all of the downsides to this agreement. There's an involuntary relocation of these medical experts. There's doctors that are reported in Venezuela that have poor services due to low wages. And then the one thing we do have to look at is that Cuba is dependent on imported oil. The dependence can bring about a lot of economic instability. So there's a lot of reasons to look to other places to implement new technologies. And one of the main reasons we're looking at in this project is human rights, getting our people back home safe and where their knowledge can be treated as like an expert, not as a trade bargain. So we're going to look into an ideal energy method, which we want to have something clean, something self-sustaining, effective, good investment, and non-variable. And Eric's going to talk to you a little bit about our geothermal energy.
Okay, so that's the lead. As Regina was mentioning, Cuba is provided 100,000 barrels of oil from Venezuela. Our proposed method is designed to meet the deficit that Cuba has, which is about 40,000 barrels of oil equivalent in energy, whereas they take the remainder that they receive from Venezuela and re-export for a pure profit. Geothermal energy can be summarized by this image here, where the heat of the earth is harnessed and converted into electricity through a process which we'll go more in depth into later. It's currently being used around the world in places such as Iceland, New Zealand, the United States, Philippines, Mexico, Italy, and Japan. The heat sources which are used for this application are different natural occurring sources such as volcanoes, geysers, hot springs, fumaroles, and geothermal fields. The pros for geothermal energy is that it's essentially unlimited once you're able to tap into the heat of the earth and harness that effectively. It's independent of the weather conditions, whereas some other sources, such as wind energy and solar energy, rely on the location of the sun and the rate at which the wind is blowing. It's clean with minimal carbon emissions. It requires little maintenance once the initial system is installed and effectively operating. And we know that it can be successful because it's been implemented in the past and effectively used in different parts of the world. The cons are that it requires a large initial investment to harness the heat source and establish the initial facility to produce the power. And obviously requires a significant heat source that can be harnessed within a reasonable proximity to where you wish to distribute this power. One of the countries that it's been most effective in is Iceland, where they have 5 major plants located across their country, which accounts for over 26% of their total energy needs and 87% of their heating and hot water for all the buildings in their country. To put this number into perspective, as I was mentioning, Cuba faces a 40,000 barrel oil of energy deficit, and Iceland produces about 10,000 per year, or I'm sorry, per day. This map shows the hottest known regions on the Earth. As you can see, many of those countries I previously mentioned are located in these regions, and Cuba is also conveniently located in a very hot region. So the heat source near Cuba is located in the Cayman Trench. It has been recently discovered by the United Kingdom oceanographic scientists approximately 2 years ago. And this heat source is called a black fumarole, which is kind of a small version of a volcano that expels extremely hot fluid at high velocities from very deep in the ocean, about 16,500 feet below the sea level at extremely high pressures. The fluid being expelled from these fumaroles is known to be about 450 degrees Celsius, and the chimneys are known to be as tall as 2 stories. The black fumarole is the way that it operates is that water seeps into the earth and accumulates different minerals from the earth's crust, in which are then re-expelled through the fumarole. The fluid being expelled contains various minerals such as zinc, copper, lead, and hydrogen sulfide, which is known to be dangerous. The method that we propose to harness this fluid takes care of the danger from the hydrogen sulfide, in which it's a closed system where no people have to come into contact with the fluid. It's known as a binary cycle power plant, in which the hot fluid is passed through a heat exchanger, in which the heat is exchanged to a fluid with a low boiling point, such as a butane or a pentane, which is then converted to steam, which is used to turn a turbine, and in turn generates the electricity that can be distributed amongst the island.
So for the application of the geothermal facility in Cuba, we believe the best place would be Cienfuegos. This location already has power plants available to it. It's very central in Cuba, as in the power from this area reaches throughout the island, and it's very close to Cuba's main tourist attraction, which is Havana. So the installation of the pipes would just be installing the pipes into the mouth of the fumaroles in order to access the the fluid that's being expelled at these high temperatures and velocities and maintain that pressure and velocity. And in this way, the minerals that are in the water, it will not precipitate because it never comes into contact with the cold surroundings. So the things that are dissolved in this fluid stay dissolved throughout the entire system. So the system requirements, these are estimates based on other areas where geothermal facilities are being used, but the most important thing here is we use martinistic stainless steel. This is this steel is very corrosive resistant, so it will be able to be resist the sulfides and the other corrosive materials that are being expelled by this water at these depths. And we also need to use polyurethane for the pipe insulation. This will maintain the heat of the water as it gets to Cienfuegos. And as it goes back, that's really not necessary. So the polyurethane coating will only be used for the initial transportation of the water from the fumaroles. The system cost in total, it's going to come from, well, in total it's going to be $14.5 billion. And the expected output will be about 1/3 of Cuba's energy needs, which would cover the barrels of oil that is trading with Venezuela. So this will effectively be able to replace the trading that is necessary for Cuba to maintain its energy needs. And the challenges that we're facing is finding the fumaroles, the insertion of the pipes, the using of long-resistant corrosive materials, generation of steady flow, and maintenance of the underwater pipe. Some of these can be solved by using already used practices. For example, maintenance of underwater pipes. There's a lot of systems in place with oil companies that are drilling in deep sea oceans. So these are just some of the main challenges we'll be facing with this implementation.
Some of our economic impacts are listed here. One of the major ones is job creation. Throughout the process of building and running these sorts of plants, you have jobs in startup, exploration, drilling, construction, operations, and management. It's forecasted by the Geothermal Energy Commission that approximately 800 jobs are created when a geothermal energy plant is built. Another thing is that this also creates career diversity. Development in the electronics market. During the 2006, Cuba had an energy revolution, as they called it, where there was a lot of sales of new appliances, and which stimulates the economy. Increases in economic stability, as Regina mentioned. Less dependence on foreign oil. As we know, oil changes prices from day to day. So if you can provide your own energy, you don't have to put up with this instability. Tourism is obviously a big industry for Cuba, especially in Havana. And as there's a better development of infrastructure, that promotes more people to visit the country, as no one wants to go to a country that has frequent power outages and an irreliable power grid. Ecological impacts, as you can see here, the geothermal energy offers close to zero emissions, high efficiency. As Eric mentioned, it's non-variable. We aren't counting on wind or sunlight. It's always there. You can run it virtually 24/7. It adds to the Cuban efforts towards green technologies. Cuban government has focused in recent years towards moving to green technologies. As for negative impacts, as we said, it's a closed system, so these minerals and nutrients aren't being released from the fumaroles into the ocean, but they can be filtered out of the water and back into the ecosystem to avoid this. Political impacts. There's a bit of an overlap here with the economic impacts. There's the end of the dependence on Venezuelan oil, so Cuba can operate independently in this facet. Reduction of unethical trade. Trading doctors for oil, as Regina was mentioning, is a bit unethical. These are professionals, not trade pieces. And this would issue in a new motivation for trade. All of a sudden, we're trading for diplomacy and for profit rather than for necessity.
So in order to conclude here, we just wanted to wrap things up by looking at the benefits of implementing this geothermal energy system. And in order to look at the energy independence, we have a long-term sustainable energy and a decrease in Cuba's medical internationalism. And then we also have a little video for you guys to see, just depending on this implements, it shows the different steam, how steam can create this power from physical.
Greetings, ladies and gentlemen. This is a device that we've created as Team UF-Aceiti Acere to demonstrate the power of geothermal energy. Here we have a boiler intended to represent the effects of a black fumarole. And here, this represents our pipelines going from the black fumarole to our turbines. And since it's difficult to model a small-scale turbine, we've used a piston. And as you can see, pressure generated via steam energy can be converted into mechanical energy to move a piston up. As you can see, this piston has moved up high enough to release steam through these holes that we've made in the syringe as an escape for the steam. And as you may be aware, mechanical energy easily transfers to electrical energy to satisfy Cuba's energy needs.
And that was our little project.